So, hi everyone. Please take your seats. Actually, thank you for coming, and I didn't expect you to be so many people here, but thank you so much. I hope you'll find something interesting during this talk. So today we'll talk about how to build microservices with Kotlin and gRPC. And usually when I start this talk, I ask people if they're familiar with Kotlin. I'm not sure that this question is relevant here, but please raise your hands if you know what Kotlin is. So I really like you. You are the best audience. So the next question, if you're familiar with gRPC. Oh, too many people. I don't know what you're doing here because I'm not going to talk about some hardcore things, but I hope you'll find something interesting. So a few words about myself because I'm here for the first time. It's my first Kotlin conference. I'm a little bit nervous. So I'm a software engineer at company Wix. Maybe you've heard about this company, but if our advertisement hadn't reached you, I'll tell our marketing team, and you'll probably see our advertisement in YouTube. So Wix is a great company, and because even without knowing some technical stuff, even without any degree in computer science, you can build a website for yourself and earn some money or do whatever you want. And actually, we try to change lives of people. So this company is great, but my talk is not about my company and about all the stuff we are doing here. It's about my experience, and all my thoughts are only mine and not my company's. A part of working full-time at Wix, I am also an active community member. I organize Kotlin user group, Kotlin Night in Kyiv. I'm also in program committee of different conferences. So if you're interested in, you can follow me, you can ask me, And I also write some posts in Medium, and you can also follow me on Twitter because sometimes I post some funny stuff. So one really important thing you should know about me, I do boxing. I like it very much, so think twice before asking tricky questions. When I did this joke a couple of weeks ago in my company, where we mostly use Scala, one guy said that now Kotlin team make this aggressive marketing. Yes, and I think that we should, because Kotlin is great and we should be more aggressive in propagating it. Of course, it's a joke. I won't hit anyone, at least today, because I am in a good mood. So let's proceed. Today we'll talk about gRPC in general, what it is, because half of the audience still don't know what it is. Then we'll implement some very simple service, and then we'll re-implement the service using Coroutines, and we'll understand how we can benefit from it. After that, I'll show you some cool libraries, especially for Kotlin and gRPC, and explain you how to use them and what can be done with them. So before we start, the talk is sounds like building microservices with Kotlin and gRPC. But in the very beginning, if you started your career 10 years ago, 7 years ago, or even earlier, you probably wrote monolith. And I think that a lot of people are still writing monolith. But in some point, in some moment, a big monolith split it into many, many microservices. So in the very beginning, it was a monolith, and then we started doing microservices. So please raise your hands again. It's like a workout. If you're doing microservices today. A lot of people, you are really progressive people, because at some conferences, just 2 or 3 people say that they are doing microservices. But today, microservices is a really huge trend. Why? Because it's rock. You see, I'm a hard rock girl, and I like rock. Why? Because we can be independent. We can do whatever we want and in small parts. And one microservice can be written in Kotlin, another in Java, another in Scala, in Python, Go, Rust, whatever you want, and it will work together. Sounds like a magic. It's scalable, because scale small parts is easier than scale big parts. Like if you're scaling big monolith, it's quite expensive. But if you're scaling some small parts, you can be more flexible. You can decide which microservices you need more instances, which fewer instances, and you spend less money. You can choose best suitable tool, as I already told you. We can develop something in Node.js, for example, another microservice in Kotlin, and be happy. And of course, we can do parallel development, because if some teams are working on their own features. We just define the contract, some interface, and then teams are working independently and in parallel. And of course, it makes our company to earn more money, to develop quicker, and be happy, and et cetera, et cetera. So microservices is really cool concept, and I think that it's like it can help us very much. But we cannot talk only about pros of microservices. There is one but, one big con. Let's talk about it. The biggest issue in changing a monolith into microservices is changing the communication pattern. What am I talking about? When we are writing monolith, like a few years ago, and we are just triggering another service in your server. It's like your own method and another function, and it's like under your hands, and you can easily use it. But when you split your monolith in a lot of microservices, like at some point you understand that you have network. A network is something that is not reliable at all. So it's something that could be down at any time, and you can do anything with it. Also, if you're using network, you have latency. So if you just trigger another service on the same server, it's okay, and it's quick. But if you're using network, you add some latency. And it might be not that good. And of course, communication makes writing microservices a challenging thing. By the way, do you know who said this? Any ideas? Okay. He is a cheater. He saw my talk. Yeah, it's Martin Fowler. And if you don't know this guy, you probably should find him and find his articles, his books, because he's really smart and he has really smart thoughts. So we are writing microservices, most of you, but what do we use for writing microservices? Most cases we are using HTTP1 and REST. So please raise your hands if you are doing this. Don't be shy, it's not a sin. Actually, at Wix we are also using REST and HTTP1. Not like everywhere, but we still have these parts. And it's not bad, so it works for us, it's okay. Why should we use something else? But for example, at Wix, we faced one small problem. We have 150 million of clients. I think at this point it's 160 million of clients. It's millions of requests per day, per second, per minute, and we need to handle it somehow. And we need to buy more and more servers and to pay more to Google Cloud, to Amazon, and it's all about money. It costs money. And the more your company pays for your infrastructure, the less it pays to you. Are you happy with it? Me not. So I think that I want to earn more money and to reduce costs of my company for more infrastructure. And we decided to think about something else. Maybe there is a way to reduce our costs in some point and to spend less money on infrastructure without changing a lot in the code. And here comes gRPC. gRPC is not the only solution, but it could help. So let's discover what it is. I have a riddle. Do you know what gRPC stands for? So you probably should understand that it's an acronym. Maybe you know how to what does it mean? Yeah, most people think that it's Google Remote Procedure Call, but surprise, it's not true. It's a recursive acronym, and it means gRPC Remote Procedure Call. Actually, I had the same face palm and think that what the hell it is. And then Google guys, they decided that it's not good stuff. And it's not true anymore. So then they said that for each new version of gRPC, they have new meaning. Maybe at some point they just will like run out of words starting from G and okay, it was funny stuff. We know what's G. But what the hell is RPC? Do you know what is RPC? Actually, RPC is not a new concept. It's a remote procedure call. What does it mean? In simple words, it means that you have some function, some interface that you can use, and it is your own. It's written somewhere in your code. But under the hood, it's something written by another one. It's something could be on another server and another site, and under the hood you are using network for calling it. But you think you treat it as it's your own function. There were different implementations of RPC, like Corba, RMI, and people were not really satisfied with it because it was complicated, the code was ugly, and they don't like it. And actually, RPC for many years was not good stuff. But gRPC, developed by Google, is the same RPC, but with really cool interface. So you can, it's friendly, you can use it, and you can write like simple, elegant code, and that's why it's getting its popularity really fast. So let's talk about its features. Why gRPC can help us to reduce costs, because we need to understand how it works. First of all, gRPC is built on top of HTTP2. So do you know what is HTTP2? I'll tell you a little bit about the protocol evolution. In 91, we had HTTP 0.9. Then 96, it's 1.0, 97, 1.1, and then no progress, no progress, no progress. Maybe they're not alive. Yeah, I think they're dead. And suddenly, in 2015, HTTP2 appeared and said, like, I'm alive, I'm still here. Of course, it's a joke. It doesn't mean that they did nothing for the whole decade. But what I'm going to tell you that everything changed. Like the whole life changed, the whole internet changed, and we really need something new. But if we look back a few slides ago, we can understand that most of the people are still using HTTP1, which is not that good because it's the protocol from '96 year. By the way, do you know that HTTP3 is appearing? It's going to be soon. So we probably should switch to HTTP2 or HTTP3 soon. So using HTTP1 is not cool today. Think about it, please. So why HTTP2 is so cool? First of all, finally, we can have single TCP connection. So in HTTP1, you could have keep alive, but it was failing at some point, and it was difficult to work with it, as I remember. And finally, HTTP2, we just keep this single connection, and you do not open new connection for each request, which is quite optimizing. Then you can have, as you have this connection, you can have bidirectional streaming. So you can use this connection for streaming, and not only for server streaming, but for client streaming, which is quite revolutionary. Because even with WebSockets, you still can do this with client streaming. Also with HTTP2, you can do flow control. Just you can define how many requests you can handle from your server, because sometimes there are problems with it. I think that there are a lot of Android developers here, and you know that mobile phones are not that smart and not that cannot handle all those requests as, for example, my laptop. And it's quite good to have this solution to say, server, please send me a bunch of requests. I'll cope with it, and then you'll send me more requests. So flow control is a really cool feature, not to make your client down and to keep your clients satisfied. OK, that's enough with HTTP2, because we can talk a lot about HTTP2, but our talk is not about it. So gRPC also supports multiple languages. As I already told you, you can use Kotlin, Scala, Java, you can use Go, you can use JavaScript, TypeScript, C#, whatever you want, even Python. And one of the main features of gRPC, which really makes it cheaper and can reduce your costs, is binary. Because HTTP2 protocol is finally binary, and Protobuf, which is used in gRPC, is binary protocol. So now you are not sending strings using HTTP1, but you are sending bytes using HTTP2. And bytes are cheaper than strings. So it works. In Java, we have implementation for gRPC. And Java really likes gRPC. I know a lot of people who are using Java and gRPC and are happy with it. In Wix, we also decided that gRPC is cool enough, so we can try it. We tried gRPC and we like it. But there is a small problem at Wix. we have Scala. And so it's not a small problem, it's a big problem. Okay, so Scala is not supported like officially by gRPC. We only have gRPC Java, but there is a really cool library called Scala PB, which makes writing gRPC in Scala even not that painful, but even better than with Java, because Scala PB adds a lot of features. You can use futures and all Scala asynchronous stuff and be happy with it. And if we can do this stuff with Scala, we think maybe we can do this stuff with Kotlin. And that's how actually this talk appeared and how I started investigating this. So we discovered a little bit gRPC. Let's proceed. I've told you that we are using protocol buffers for for transferring data in gRPC. So let's talk a little bit what is Protobuf. So Protobuf is Google's language natural platform natural mechanism for serializing structured data. So in simple words, it's like XML or JSON, but smaller, faster, and simpler, and so on. Why is it so? Because in Protobuf, we have this pseudo language, and we can define this file. So you just write proto file, and your proto file, you define your service. For example, we have service greeter. Here, do you see it? Yeah. And you have method say hello. It's RPC call. And in this method say hello, you have hello request and hello reply. And a little bit lower, after the service, you define what is hello request and what is hello reply. So in our case, it's just string, but you can have a lot of different fields there. So in just like you're just writing like some code, and then you define this proto file. It's compiling, and then you get implementation of this, like not implementation, but you have these classes compiled in the language you're using with the plugin you're using. So you can compile it to Java, to Go, to Dart, to Ruby, C#, whatever you want, and so on. So let's a little bit summarize what's Protobuf. Protobuf is type safety. Why? If you are talking about a Kotlin or Java or another static type language, you can see that you have classes also in your static type language. And you cannot violate these classes. So if you are passing something else, you have compile time error. You also cannot violate schema. For example, it's quite difficult to send in say hello, no, not hello request, but some integer or something else, because you get compile time error. So you cannot violate it because it's a compile time check. As far as we are working with binary, it's bytes, it's fast. So serialization is fast. And one of the coolest feature of Protobuf is backward compatibility. If you want to add some new fields into your messages, you can add it easily or deprecate easily, because all these fields are optional. And it's quite good because at work I'm doing it all the time. We all the time need something new. We need to deprecate something old. And it's quite easy to do this because of backward compatibility. But the main problem of Protobuf is lack of human readability, because if you are debugging it and at some point you need to understand what was sent, you just get bytes. And if you can't read bytes, you're in trouble. So that's enough about Protobuf. If you want, we can talk more about it after the session. Let's implement some service, because I'm talking a lot. I see you're a little bit tired, or not. So we'll implement it. As you can understand, I am a big Star Wars fan. You see, my friends are here. So, and today I decided that I need a Death Star. I need this tiny little Death Star to destroy universe. So there is a small task for this session. What should we do? First of all, we need to write this Death Star. And then we need to destroy as many planets as we can. Then we should tweet about it, because if we don't tweet, think that it won't happen. So you should tweet. And I'm a little bit lazy person. So this demo is already running somewhere in the cloud, and you can play with it. And 2 winners will get these prizes. So if you are a Star Wars fan, you can win it. And of course, enjoy. I hope you'll enjoy it. Application is here. If you want to play, just actually, I didn't expect that I'll have too many people here. So I'm not sure that our server will handle all this stuff, but shit happens, so sorry. I hope you'll have fun. Actually, there is a really smart algorithm, so not every planet can be destroyed easily. You need to put your effort there. So I think I can proceed with slides. Yes? So let's look forward. And now I'll explain you how this application works. In this application, we have two main flows. First flow is when user join. When user join, you or me, I will go to the star service. It's my first microservice. And the star service goes to planet service and asks how many planets and which planets do we have in our solar system. And then we have a response, and we notify our user to paint our universe. So that's how the first stuff goes. And then we want to receive some logs. What was happening, who joined, who destroyed something, and we subscribe for logs. So we go to log service and have server streaming from it. And then we go to score service in order to see how many people joined, how many people are playing, and their scores. And asynchronously, we are receiving these server streaming results. So we are subscribing to log and score service and receiving results asynchronously. It's when user joins. The most interesting stuff is when user destroy planet. So when you click on planet for many times, and at some point planet was destroyed, we send a request streamingly into the star service. If planet was destroyed, we are going to planet service and remove one planet because it was destroyed. But we are a little bit cheaters because we don't want our universe to die at all, and we generate a new planet. So we send this new planet to our service, and then we log everything, update scores, and update our user asynchronously. So your screen is repainted asynchronously. Let's implement this. First of all, we need to start with protofile. Here is our protofile. We have the star service, one method destroy, and you can see that in this protofile we have this keyword stream. It means that our destroy method is bidirectional streaming. So we are sending requests, like stream of requests, and we are receiving stream of requests. And it's a cool feature of gRPC, because you can do this bidirectional streaming even using only one call. And here are messages. Planet, like planets, and destroy planet request. And then some magic, and all the stuff is compiled to Java. Unfortunately to Java, because we don't have a Kotlin plugin officially, and we need to use gRPC Java and build something on top of gRPC Java. This code is a little bit ugly, so I don't want to make violence to your brain. I just show only declarations and won't show you what is under the hood. If you want, we can talk about it later. And we need to code something, and we have this server. We define this server, and we see that in this server we need to add service in order to make our service work on this server. And this service is called the star service impl. And we need to code, and now I need to return to my code. Oh, so I am a little bit lazy. I am a little bit scared to do live coding because all the time when I start in live coding, I forget how to type. I forget everything. So I'll just show you what I have, and we'll explain it. So when we're using gRPC Java, you see it's about gRPC Java, what do we have? We have this destroy method. First of all, we subscribe. So we add our observers to listeners in order to receive updates about what's happening in our solar system. Then we need to paint the whole our universe for the first time, and we ask our planet service to send our all planets there. So we are getting all planets. And you see that we need callback here. And in this callback, we are doing this with our response observer. OK, as far as we have bidirectional streaming, we need to do we need to return stream as well. So what are we doing? We return stream, and in stream, in callback, what we are doing? We remove planet. If planet was removed successfully, we are doing again a callback. And what are we doing again? We're updating scores, we log, we generate new planet, and after new planet was generated, as far as we want to reuse this result, in the callback, we log everything, and we notify all our listeners that our solar system changed. So I don't know if this code fits my screen. Yeah. OK, we implemented. Let's return to code. Well done, yeah? You see that something strange here. So there is a big problem here. Please put your hand on your heart and say if you like this code. I can't do this. It's ugly. It's like I don't want to write it. And if people say me that I need to write it every day, I just better shoot myself in the head than write it. Because you can see, and what's disgusting here? There is disgusting silhouette, which I hate. And this situation is called callback hell. Because all the time, when we need to reuse a result from previous call, we need to send a callback there. And it's like stupid, because callbacks is not what we need here. We are using Kotlin, we want coroutines, we want this better stuff, we want to live in better world. So, first question, why don't we use futures? So it's obvious, and we can do this, and even with Java, we can use something reactive, or I can use completable future. So why don't we use futures here? And we can do this. Let's return to our code. So I just wanted to show you how ugly it could be. But it's not that bad. So yes, I'm doing this cheat again. So what do we do here? We launch coroutine here. Not that global scope is not that good. You'd better use some another coroutine scope, but it's a demo. So don't do what I do. So what I want to show you. We do the same stuff here. We send in get all planets, and we send in these all planets to our response observer. But what's happening? Our stop is now future stop. You can see that it's future stop. And now we have this method await, because this is future, and we can add some extension, and we can have method await here. And now you can see that this is a suspension point, and this function is suspend. So now we have this result of all planets. We don't need any callbacks. We just can send it to our response observer. Then again, we need to return stream, because we are working in bidirectional streaming. And after that, we do the same stuff. We remove planet. We are reusing result. Again, we have suspension point. We destroy everything. We generate a new planet. And again, we don't have any callbacks with new planet. We just make straightforward code. So it looks much better. So it looks this way. And please raise your hand if you like this code. Remember about boxing. So this code is not that bad as it was, but it's not that good that I want to use. So here comes gRPC and coroutines part 2. Because it's not enough only to use futures, we need to have something else to get rid of this stream observer at all. Why? Because we are Kotlin developers, and what do we have? We have channels, and we have coroutines, and we can use them. So the problem is that it's quite difficult to do this. We need to implement some bridges on top of this, and we need a hero who can do this. And first hero who I found was gRPC Kotlin. It was quite an interesting library, which was really easy. And actually, some part of my demo is written with gRPC Kotlin, and it works. So let's go into code and find how we can use this. So, sorry, here it is. Yeah. So again, I'm a little bit cheater. So what do we see here? Here, we do not have any returning of stream observer. We have this cycle. Why? Because for now, we do not have stream observers, we have channel. Our requests are received channel, and we are returning also received channel of planets. So we generate this channel, and we are iterating all our requests. So we are using it as it is some collection. We are iterating over it with cycle 4, but under the hood, we have coroutines and suspension here. So it's more straightforward and more declarative way than it was with stream observer. So what do? Again, we are removing planet, we are adding scores, we are logging, and we generate new planet, and we notify everyone. So now code looks this way, and raise your hand if you like it. Don't be shy, because I don't have a better solution for now. So what I like about this code more than about previous, we only see business logic here. There are much less boilerplate here. All line of code do something smart, do something for business and not for infrastructure. And that's what we want in Kotlin. That's why we switch from Java to Kotlin. And that's what we need. And our Dart Trader is happy. But wait a minute. I lied a second ago because I have a better solution. We have another hero, and another hero is CrotaPlus. It's one more library. It's really huge and interesting library, and I think you should probably look into it. And even an author of this library is here, and I'll show him to you. So we have another hero, CrotaPlus, and let's look in code how it looks. So it looks pretty similar to previous one, but then we see that there is we do not return channel. We have this request and response channel in parameters, and that's why we can eliminate some problems with some hanging channel, and we can have less code here. And you can see that even here we have even less boilerplate than before. You can see. And again, we are doing the same stuff. We are iterating over requests. We are removing, we are adding scores, we are logging everything, generate new planet, log, and notify everyone. So code looks, with CrotaPlus, code looks this way, but it's not the only feature of CrotaPlus, because you can extend and you can even write your extension for how you want to compile your Protobuf, and so on, and you should definitely look into this library. So now the destroy method looks this way, and I even like it more. So please raise your hand if you like it as well. Yeah, I think I had a small workout during my session, because all the time you need to raise your hand. So if you all become fit after my talk, it's my thing. And let's talk a little bit more about libraries for Kotlin. When I started looking into this stuff a year or more than a year ago, I thought that Kotlin is so cool, gRPC is so cool, and I probably have these cool, amazing robots who can save my life, who can do everything for me. But then I found out in reality that we have this kind of guys that can't really shoot anyone in 8 episodes. Why? Because it was a year ago, and not a lot of people looked into gRPC and Kotlin. So first thing that I found out was gRPC Kotlin. I was really happy to find it, because I thought that it's official from Google because of gRPC Kotlin. Then I found out that it's in someone's repository, and it's version 002. And there is a message that it's a prototype, so don't use me. I was a little bit sad because I wanted to use it in production, and but I was said that it's not smart. And I just looked into it and decided to write my own wrappers for the gRPC and Kotlin. But in few months, I found out that it's version 0.1.2, and I liked it. Because it was a really huge job done for this library. And now my demo is almost written using gRPC Kotlin. So I hope it works. And I really like it, and because it's very simple. And if you just want to have some simple stuff for gRPC in Kotlin, you can use this library. But if you want something more, there is CrotaPlus. When I first come into this library, it was quite interesting for me. But again, it was 0.1.3 version. And I didn't know how it will be released, and so on and so on. But today, see that there is a Slack channel. There is version 0.5.0. And for now, I think it's going to be released soon. And there is a logo. And it's really an amazing library. I think you should probably look into it. And you can see the message that community contributions are welcome. So if you want to make it faster to release, if you want to make it better, to make life better, so you should probably contribute there, or maybe write your thoughts how you see this. And I think people who develop it, who contributed in that, deserve applause and deserve some thanks to them. So some useful links about from my talk is some repositories from Salesforce, it's gRPC Java Contrib Reactive gRPC. It's even if you don't use Kotlin, you're with Java, but you don't want to write this ugly stuff, you can look into these libraries because they implement some stuff with completable features, with reactivity, and the code, even in Java, is not that ugly. There is also a Protobuf library for PB and K for Kotlin. It's quite interesting. I tried to use it at Wix, but it was not. We had some problems with it, but it's not because of this library, it's because of we have Scala. But actually, this library is really interesting. And if you want just to use Protobuf and Kotlin, it's okay to go there and to look into it. And then, of course, I have link to my demo. If you want to play with it, want to add something, want to fix bugs, so your contributions are welcome. And one more stuff, the last link is about performance. At Wix, we still don't have these benchmarks, how gRPC helped us or not. But I know that guys who made this investigation, they had some interesting results. And if you're interested in it, you can look into it. So when I started doing this talk, all the time I said that one day we'll have a stable Kotlin support, blah, 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 because libraries were not released and I didn't know about the future. But today, for the first time when I'm doing this talk, I'm saying that we finally have a stable Kotlin support and you can use it in production. And I think that soon a library like CrotaPlus will be released and you can use it. And I can say that it's really cool. So time to summarize. First of all, you can use gRPC for effective communication. Even if you don't use Kotlin, if you use Java or even Go or TypeScript, gRPC can help you. So you should not ignore it. Then, if you want to use gRPC in Kotlin, you can understand that things will be easier than with Java. So you should look into it. So gRPC plus Kotlin can be used today, and you can make things easier. We're waiting for first release of CrotaPlus, and I think that we should add flows there. And I hope it would be even better than with channels. And feel free to contribute, of course, because it's open source. And people who are working in it, they have their daily job, and they don't have much time to work on it. And your contributions are really welcome. And the last point, don't use gRPC. What am I talking about? I'm talking a lot about gRPC, how it's cool, how it can reduce your costs. But the main thing that I talked about Wix, about our company, with 160 millions of users, with millions of requests per day. And yeah, we need gRPC because it can reduce our costs. But first you should think if you really need it. Because if you have one customer and one request per month, maybe it's okay to live without gRPC with REST and so on. So you should think if you really need it for your scale and to reduce your costs. Because benchmarks say that if you don't have high load, you don't need gRPC. As I already told you, we need to define the star master to give this presence. So let's look into demo. I hope it's working. Oh, lots of people are here. So, Daniel Weber and Jonathan Ward, you should come to me after the session and decide who takes what. Okay, so after the session, just come to me. And it's time to say thank you. There are a lot of people who are behind me who helped me to make this presentation not that ugly. And first of all, it's Ray, who was developer advocate for gRPC and who pinned me in the right direction and showed me right people and right repositories. And these two guys are authors of Kotlin gRPC and CrotaPlus. And they did really cool job. And they helped me a lot. And I really appreciate the job they did. And of course, my slides. Here are my friends who reviewed my slides, who helped me not to be afraid of you, like this. And this guy, do you know who is he? Yes, you're my favorite audience. There are some people who don't know who is he. It's George Lucas, yeah, his father of Star Wars. And of course, thank you for sitting here, for having me here, and thank you.